Hi, I'm RL from MathinSG.com. In this video here, I'll be going through paper 1, question 9. The full work solution can be found here, link in description below. So now let's take a look at question 9, which is a parametric equation question. So you're given a curve with this parametric equation, x equals to 3t squared plus 2t, y equals to t squared plus 2t cubed, and you need to find dy dx in terms of t. So in order to find dy dx for parametric equation is equals to dy dt over dx dt. Okay, so what we need to do first, we need to differentiate x in terms of t and y in terms of t, then we can sub it in here to find dy dx. So let's find dx dt. It is equals to 6t plus 2. dy dt is equals to 2t plus 6t. Okay, so let me factorize out this because I need to leave it in terms of this way. Sorry, there is 2t plus 6t squared. Okay, so let me factorize out 2 from here. It will give me 3t plus 1. Let me factorize out 2t here. It will give me 1 plus 3t. Okay, so dy dx is equals to dy dt divided by dx dt. Okay, which is equals to this 2t 1 plus 3t over this 2 over 3 plus 3t plus 1. So this can be cancelled off and you'll be left with t. So comparing this, dy dx equals to kt and dy dx equals to t, I know that k is equals to 1. Next, the tangent to C at point P makes an angle of 60 degrees with the x-axis. Find the exact coordinates of P. So I know that there is this tangent, let me just call it tangent. Maybe this is the point at P. Okay, and then it makes an angle of 60 degrees with the x-axis. So if it makes an angle of 60 degrees with the x-axis, what does this tell us? It gives us information of the gradient. Because gradient is equals to tangent theta, where theta is the angle made with the positive x-axis. Okay, this one came out a few times in A level, so make sure you know the angle a line mixed with the x-axis, okay, is related to the gradient. Gradient is equals to tangent theta, where theta is the angle the line mixed with the positive x-axis. So I know gradient of tangent is equals to tangent 60 degrees, and tangent 60 degrees is essentially root 3. Okay, and gradient of tangent is equals to dy dx, right? So, and I know that dy dx is equals to t. So I know that, okay, when dy dx is equals to root 3, t is equals to root 3. So at P, what do we know? T is equals to root 3, right? So once we know that at P, T equals to root 3, what can we do? Well, we can find quite a number of things. Okay, we can find the x and y coordinates. And that is what we need to find the exact coordinates of P. So we just need to sub in T equals to root 3 into the equation. So we just need to sub in root 3 into x and root 3 into y, and then we'll be able to find the coordinates of P. Okay, so let's do it. Okay. So x is equals to 3t squared, right? T is root 3 plus 2 root 3. Okay, so this root 3 squared is 3. 3 times 3 is 9. So it's 9 plus 2 root 3. Y is equals to t squared plus 2t cubed. Okay, so it's root 3 squared plus 2 root 3 cube, right? Okay, so this will be equals to root 3 squared is 3, then it's essentially this. So it is 3 plus 6 root 3. So the coordinates of P is 9 plus 2 root 3, 3 plus 6 root 3. So this is the answer for part B. Moving on, the point Q with coordinates of this lie on C. So if this point lies on C, that means it satisfies the equation of C, right? That means we know that 16 is equals to 3t squared plus 2t, because this is the x and this is y. And then 20 is equals to t squared plus 2t cubed. Okay. We also know that t is greater than or equals to 0 according to the question here. Okay, so coming back to here. Using calculus, find the exact area of the region bounded by the curve C, the x-axis, and the line parallel to the y-axis through Q. So let's start off by sketching the curve. So this is my curve. Okay, so use your GC to sketch it out. So now I know that this is my y, my x, and this one is, if you use your GC, you'll notice that it passes through the origin, and this is point Q, which lies on C, it's 16, 20. And you're asked to find the area of the region bounded by this curve here, which is the blue line, the blue curve, the x-axis, which is here, and the line parallel to the y-axis. So the line parallel to the y-axis is basically any vertical line that passes through Q. So the vertical line parallel to the y-axis that passes through Q is basically x equals to 16, because the x coordinate of Q is 16. Okay, so now I need to find this area, right? So what do I need to integrate? So, well, I need to integrate from x equals to 0 to x equals to 16, the y dx. Okay, but what am I given? Well, I'm given a parametric equation, right? Everything is in terms of t. Okay, so what do I need to do? Well, I need to change all these to t because y is in terms of t. So I need to integrate in terms of dt, and these limits here need to change to t also. So when x is 0, t, which is equals to 3t squared plus 2t, is equals to 0. So let me factorize it. I know that t equals to 0 or t equals to negative 2/3. And we are also given at the start of the question that t is greater than or equals to 0. So I'll reject t equals to minus 2/3. Okay, so I know that when x is 0, t is 0. Next, when x is 16, now I have 3t squared plus 2t equals to 16. Okay, basically this is a quadratic equation. Use your GC to solve it. Okay, and you will get t equals to 2. Okay, because we are going to reject all the negative values. Okay, so now I know that I have when x is 0, t is 0. When x is 16, t is 2. My y is t cubed plus 2t squared. Next, because everything is in terms of t, I cannot have dx. I need dt. So let's differentiate this to get, or we have already differentiated this. We got 6t plus 2, right? So we need to replace our dx with dt. So if you look at this, this is essentially 6t plus 2 dt, right? So we are going to replace our dx with this, but this is mathematically wrong, so don't write it. Okay, but we know that to change dx to dt, we will just split it up. Okay, so I have 6t plus 2 dt, and because they want you to use calculus, that means without using the calculator, you have to expand this. Okay, so you need to expand it, and then you integrate. This is basically just a simple term, a simple expansion and algebraic integration. And And the answer for this is 1832 over 15 units square.